No geology YouTube channel is complete without a arm-waving video about how Yellowstone is going to kill us all, right? The Yellowstone supervolcano. Well, actually, I'm not really even going to talk about the Yellowstone supervolcano yet, but I do want to talk about supervolcanoes and something that isn't talked about much, which are basically volcanoes that are worse than supervolcanoes. So, what's a supervolcano anyway? Well, they're basically super large volcanic eruptions. We haven't really seen a supervolcanic eruption in recent human history. How do we classify them? Well, they're defined by having a VEI of an 8. What's VEI? VEI stands for Volcanic Explosivity Index. What is that? Well, the Volcanic Explosivity Index, VEI, is how much material gets thrown out of a volcano. Basically, how much lava and ash gets thrown out of there. And it has a scale from 0 to 8. You don't kind of see the 8 here, but I promise it goes to 8. And it's logarithmic. What's that mean? It means each number is 10 times as much as the rest. So the amount of material from a VEI 1 volcano is 10 times the amount from a 0, and a 2 is 10 times the amount from a 1, and a 2 is therefore 100 times more than a 0. And therefore a 1 is 1,000 times less than a 4. So if we're talking about the Yellowstone caldera down here, that's actually classified, a supervolcano is classified as something that is thrown out 1,000 cubic kilometers. And for comparison, Mount St. Helens put out about 1 kilometer cubed of material. So yeah, the Yellowstone caldera can put out quite a bit. That's a lot. This Tambora eruption really played a major part in history. This 1815 data. I'll probably make a video just on this at a later date. But yeah, this was the last time there was a famine in the United States. And 1815 is generally regarded as the year without a summer. More on that later. So, what's bigger than a supervolcano? What's worse than that? There's something called flood basalt volcanism. And I know it's not a great name. It's not like super duper volcano, extra crispy, major, awesome volcano. It's just flood basalt volcanism. It's just a different type. And so what are these? Basically, it's an area of the earth that just starts erupting lava like crazy. And it's not just one single peak. It's usually all over the place. It's like a rash. You can see that over here in this image pretty well. You can see all these dikes that opened up and just started erupting lava. It's not a singular eruption. These are usually multiple eruptions over time. How long of a period of time? Can be a couple million years, can be on the order of thousands of years. This isn't happening today. You maybe could argue Iceland if you kind of go back and look at some of Iceland's longer eruptions, but I'd argue that's a bit of a difficult argument to make. And frankly, it's not even an argument I'd get into because I don't have a really good understanding of Iceland's eruptive history yet. But I know it's not on the level that some of these other flood basalt volcanism events have occurred. The last real one that kind of gets talked about is the Columbia River flood basalts. And that's over here in this picture. If you look, this is the northwestern United States. Here we have Oregon and Washington above it. So very large area here. I'm likely to make a video on this later. I'll talk a little bit more about here in a second. But what other flood basalt events happened and what kind of effects did they contribute? Well, I'd argue all day that flood basalt volcanism had more to do with the dinosaur extinction than the impact event. Yes, the impact event knocked them out, but they were already having a tough go of it. It's basically like kicking somebody when you're down. And frankly, a lot of mass extinctions, it kind of takes multiple things to cause something to go extinct. Also, the largest extinction in Earth's history, the Permian extinction, also called the Great Dying. It's pretty well understood now that flood basalt volcanism in Siberia is probably what set this off. And as to quote one of my old professors, if ever there was a time in Earth's history where life was threatened, it was during the Permian extinction. And I'll put a little asterisk by that and say that, that's animal life, that's vertebrate life, that's, 250 million years ago. That's kind of ignoring anything that happened on the order of billions of years ago. So, how do they compare? How do flood basalt volcanoes and supervolcanoes compare? Well, first off, we kind of have to understand how they're potentially related. This is it's a little complicated up here, but this image up here in the top right shows the relationship of the flood basalts from the Columbia River flood basalts and the Yellowstone hotspot. And the best analogy I can kind of come up with this is, think of this like a mushroom cloud. You have a gigantic explosion. You have a whole bunch of magma that comes up in a plume, and it hits the surface of the earth, and it just starts coming out, right? It just starts erupting all over the place, and just putting out tons and tons and tons and tons of magma and lava. Then that kind of subsides, and you kind of get this trailing edge here, and that's the hot spot. That's the remnants. So the Yellowstone volcano is related to this Columbia River flood basalts, but you can see that Yellowstone caldera is a lot smaller than all the area where all these other eruptions occurred. And not only is it smaller in area, but it's smaller in volume. So these Columbia River flood basalts put out about 174,300 cubic kilometers versus about 1,000 kilometers every time the Yellowstone volcano erupts off. That's a big difference. That's a big difference, right? 174 times as much. Although the Columbia River flood basalts took about 3 million years to get through. Now, there were different periods of eruptions. You can map all these kind of lobes out and everything when this occurred, and some eruptions happen more quickly and put out more material, and you can kind of tease that out when sometimes are worse than others. And this doesn't seem to have caused any mass extinctions. This does seem to have caused a lot of changes, maybe an evolution, and also migrations of animals. So it definitely affected the environment and the global climate. More on that later, but not like some of the other major events. The Deacon traps, this is responsible for messing around with the dinosaurs, and the Siberian traps, which was the Permian extinction. And there's your comparison for material with those. 1 million cubic kilometers, and again, we're kind of comparing to this, right? 1 million cubic kilometers, and the Siberian traps are 7 million cubic kilometers. Compare that to Yellowstone, man. Yellowstone's nothing. It's nothing. And the Deacon traps, which basically was half of India turning into a volcano, most of that could have come out in only about 30,000 years. So, yeah, the dinosaurs are going to have a tough time with that. That's going to change the climate a lot by emitting all sorts of things like sulfates and lots of CO2. And generally, volcanoes don't play much of a role in terms of atmospheric CO2 and greenhouse gases. However, if they erupt for a long time and put out a lot of material, they can put out enough CO2 to make a difference in the greenhouse gas effect. But they also put out all sorts of other stuff, and it kind of depends on the volcano and what's coming out of it. The Siberian traps took about 2 million years. I've seen some different estimates on that, and that kind of changes a little bit. And as we move forward through time, the science gets a little bit more constrained with this. But over here you can see this is a map of the Yellowstone caldera and how it's erupted over time numerous times, and these are on the order of millions of years. So, every couple million years, pow, 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 pow. And why is it in a line like that? Well, that's because the North American plate is moving a little bit to the west, and that hot spot is staying put. So it's right there right now, and as the North American plate moves west, this should erupt again somewhere in here. But again, we'll go more into detail on the Yellowstone caldera at a later point. And I'll just say, those of you wishing for the end of the world so you can come out on the other side as people have fantasies about that, and I'm one of them, right? Somewhere in the recesses of our mind, it's kind of cool if the end of the world happens, right? Oh, the apocalypse. Yellowstone isn't going to do it. I'm sorry. I think I can say with confidence that there is 0% chance that that is going to happen in our lifetimes. Not near zero, 0% chance. But again, I'll make a video about that later. So, sometimes you'll see these things called traps, like the Deacon traps and the Siberian traps. Where's that coming from? That comes from the Swedish word trappa. It means staircase, and that's the effect that these flood basalts have, where you have these multiple eruption events where all this lava is coming out, and then it solidifies, and it kind of creates these stair steps. So what about the Deacon traps? This is where I was at. About half of India was this big eruptive complex about 65 million years ago. And then Siberia, and pardon the German language here on the map, but there's where the Siberian traps were. All this area is just erupting for a couple million years. And that really messes with the climate. But to kind of give a little bit more detail with the Columbia River flood basalt, there's a lot going on with this graph. One thing to look at here is this kind of purplish blue thing is the amount of CO2 in the atmosphere, and you'll notice it's been going down over time. But today we're a little bit over 400, so we've actually, in the width of a pixel, shot way up here, and today are at about right here. And so we can look at what happened during this Columbia River flood basalt event and how it kind of peaked the climate a little bit. And we can kind of look at what the world was doing. And frankly, these Columbia River flood basalts kind of set the stage for this kind of regression into a global ice house. Like there's still questions today about did this kind of cause this decline, or was it a big part of this decline? And a lot of this plays into the Antarctic ice sheet and whether there was an ice sheet in the Arctic. During this time period, there was new Arctic ice. And so here we have this time period where CO2 levels are about where they're at today. We can look at this time period and say, okay, what should we expect in the future? This was a time when a lot of CO2 is getting kicked out. You kind of had this kick up here. What was the effect of that? And there's other periods throughout, the Cenozoic. You had the Paleocene, Eocene thermal maximum, which is kind of off the graph back here. Where you had these big peaks in CO2. And we can kind of look at these things and say, okay, what happened to life? What was going on in the world to kind of, what changed? What were the reactions? And this right here is interesting because at this time period, pretty much the world looks the way it was today. The continents are where they are. They haven't moved around a whole lot since then. The types of life we've had, the type of vertebrates that are around today are pretty much all at this time period. And again, this graph in particular is dealing with apes, right? First apes evolved. This is a anthropological look at this, or a paleo anthropological look at this dealing with humans. But yeah, big things in Earth's history, and people just don't know about these very much. Maybe it's because they don't have a very sexy name, flood basalt volcanism. But when these things go off, it tends to end the world. We have all the mass extinctions that I believe are now tied to some flood basalt event that likely played at least some part with the extinction. So pretty crazy stuff. But yeah, I'll talk more later on. Put out more videos about volcanoes and supervolcanoes and Yellowstone and the type of volcanism we should look out for, and how we can even look at the pandemic and our humans' response to that, and what maybe we could expect out of a major volcanic eruption if one to occur, and how we might deal with that. So yeah, hope you learned something.